Today we're discussing our second conic section, which is the circle. Circles are something you talked about in geometry, so this should be somewhat familiar with the equations and such. There's only one equation. Sometimes it's a little different just based on where the center of the circle is, but there's no foci, there's no asymptotes, there's no vertices, nothing like that, just the center of the circle and the circle itself. So this one should be pretty straightforward. So the circle is just defined as the set of all points in a plane that are equidistant from a given point in the plane. So the center is that point that's equidistant from all the points in the circle. And the equation is the quantity x minus h squared plus the quantity y minus k squared is equal to r squared, where r is your radius, and then you take the opposite sign of h and k to find out what your actual center is. So again, just a circle is all of the points equidistant from the center point. So if we look at this, we have an equation. They give us the diameter points. So what we have to do, really, we need the length of this. So this is our diameter. These have the endpoints of this, so I need the length of that. So we need to really find the distance between that. So we're going to use that distance formula that we talked about in the first section. So we end up with the square root of, it doesn't matter which way it goes, so we can have negative 2 minus 5, the quantity squared, plus negative 6 minus 4. It has to be consistent. So we end up with the square root of negative 2 minus 5 is negative 7, quantity squared, plus negative 10, the quantity squared. So we end up with the square root of 49 and 100 is 149. I'm going to leave it as such for now. We'll kind of get to that in a second. So they want the equation. So the equation for a circle is the quantity x minus h squared plus y minus k squared is equal to r squared. Well, I need the center. So we need to figure out what is the center of the circle. Well, that's going to be the midpoint of these, because the center is right in the middle of the diameter, so I need to then go back and find the midpoint of that. So the midpoint of this is going to be 5 plus a negative 2, or 5 minus 2, and 4 plus a negative 6, which is 4 minus 6. So our midpoint, or the center, is going to be 3 halves and negative 2 over 2, which is a negative 1. So this is the center of our circle, is the midpoint of the diameter. So over here, into my equation, I have x minus 3 halves, because that's our center, plus y, it's minus a negative 1, so y plus 1 squared is equal to, now the radius is half the diameter, so it's really just this over 2. So it's the square root of 149 divided by 2 squared. So we don't have to square any of this out, we can leave this all as is. This I'll square, so I end up with 149 over 4. And you can leave it like that, you can divide that out and get the decimal. I'm okay with either way for that. So this is our final answer for the equation of a circle with diameter at those particular endpoints. Alright, so this time they want us to find, they give us an equation, they want us to find the center of the circle and its radius length, and then we're going to go ahead and graph that circle. So all of that information, the center and the radius, all of that information is in the equation. So if they give you the equation, they've given you all of that information, we just have to locate it. So the first thing we need to identify is what is our h and our k to find out what is the center of the circle. Well, the h and the k in this one are both 0, because we have x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to 25, or was equal to r squared. This is one general first. Is equal to r squared. So those are both 0, because my equation is just x squared plus y squared is equal to 25. So hk is 0, 0. So the circle is centered at 0, 0. That's our center. And the radius is the square root of this, so r is 5. So I'm going to come out every direction 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5. And that's going to create my circle. And I very neatly and carefully connect the dots. And again, it might not be perfect, but that's okay. It's close enough to get you what your equation should look like, or what your circle should look like. So graphing a circle is very easy. There's no need to plot any point or figure out any points and plug them in. You just find your center, you find your radius, and you count the radius away from the center in all 4 directions, and then just connect the dots. Alright, but this time, they gave us an equation that's not in the correct format. So what we have to do then is rewrite it so it's in the correct format. So this is where the tricky part comes in here. So, we have x squared plus y squared minus 4x plus 8y minus 5 is equal to 0. We want to do the same thing we did with parabolas and complete the square, but I have to do it with both x's and y's. So I'm going to group. We have x squared minus 4x. I'm going to group that together, plus we then have y squared plus 8y. And the 5, I'm going to move it to the other side, because you want your constant, your radius, on the other side. So I have to complete the square twice with this, both with the x and with the y. So we have negative 4 over 2 is negative 2. Negative 2 squared is 4. So I'm adding 4. Now, because it's on the other side, I add 4. I don't subtract it because it's on different sides. So what I do to one side, I do to the other side. Over here, we have 8 over 2 is 4. 4 squared is 16. So I'm adding 16 here. So I add 16 here. Again, if there's something out front, you'd have to distribute that and figure out what you're really adding. For these ones, it was both 1, so I just added what I got. So now I can factor this, and we get x minus 2 the quantity squared plus y plus 4 the quantity squared is equal to 25. So my center is at positive 2, negative 4, and my radius, again, is 5. So I plot 2, negative 4. So we have 2, 1, 2, 3, 4. So 2, negative 4, that's my center. And I count 5 in every direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I can't go lower on my board. You can go lower on your paper. 2, 3. It's all the way down there somewhere. So if I were to really draw this, it would keep going down to there somewhere. So it's down right about underneath where that tray would be, is where that's going to connect. But that's the idea. Your center just moved. We still counted out the radius from all sides. So with this one, again, same idea that we did yesterday with parabolas. The only difference is this time we have to do it twice. One for the x, one for the y. So you group all the y terms, group all the x terms, complete the squares, add those to the other side, and simplify. And that's going to get you the equation of a circle. Alright, homework is 17 through 31, so make sure you have your notes. If you want to add that general equation of a circle to your formula sheet, you may do that. Because I didn't leave a space for circles because it's just that one equation. But if you want to add that to your formula sheet, you may do that. Because that is the only equation we have to add for this particular section. Everything else, all the other conic sections have more complex value, or more complex equations.